Good morning, everyone. So we're going to have a discussion about hardware, and I changed the title slightly. Instead of hacking, I use the word playing, because sometimes the word hacking puts people off. Now, the reason it puts people off is because often the activity of hacking is presented as an aggressive one, as something that causes harm. But, well, in our community, in the free software community, open source community, we don't think that hacking is a bad thing. Hacking is a very creative activity. But nevertheless, I thought let's go with play for now because I'll correlate it to what we're going to discuss, right? So what I'm going to be talking about is how we can play with hardware, what sort of hardware we can play with, why we should be, why we should be interested in dealing with hardware. A lot of us might not, might feel scared of hardware, might not feel like dealing with it. So I'll try to, discuss those aspects as well. Now, a little bit about what I do. I have been a GNU Linux user since about 1998 when I was in college. And I've been using GNU Linux since then. I started a business in 2000 specifically so that I could work on Linux and free software full-time. Because if I didn't do that, then maybe I would have had to work on proprietary software, I would have had to use Windows or something like that. And while at that time I wouldn't have thought that it's a very big deal, it would still have been a great irritant. I wouldn't have felt good about it. I wouldn't have enjoyed it. Right? What is my function? I work with organizations, with individuals organizations of all sizes, and also individuals to help them realize the benefit of the freedom that comes with free and open source software. And what me and my team do is we try to get this software to work for them in the best way possible. I also build a lot of hardware, and some of that is what I'm going to talk about today. So consider this. I'm going to present a small scenario. Try to sort of internalize it to your situations in whichever way you can. How would you feel if your daughter asked you to show her how something worked, and you were forced to admit that you couldn't and you weren't allowed to? Right? So think about that. Let's say there is something like this. We have something to change slides, or we could have a microphone, or there could be a computer, there could be a toy, maybe there is some sort of network connected gadget at home. There's technology all around us, right? And a lot of it is not visible to us. We don't get to see what's inside. We don't even have the permission to open up things to see what is inside a lot of times. And when the functionality of a lot of hardware is designed and implemented using software, and you can't see the software, there is nothing to learn out of opening something up. So think of this situation where a child asks you to explain how something works, and your only answer is that, well, you can't explain, and you're not allowed to explain, because let's assume that product, that device or something is, the designer or the developer of the device decided not to share details of how that device was built. Now, if they had shared details, perhaps we could have sort of read the source code or gone through the schematic or the design of the board or the product itself, and maybe we could infer something about how it works, and we could explain that in a simple language to a child. So my point is that it would be scary for me, and maybe for all of us, to be in a situation where we are forced to give an answer like this. And then what is the message that we are sending out? That there are certain things that you're allowed to learn about, and there are certain things that you will never be able to know how they work. But that's not what we tell children. We tell them, look, if you want to learn something, it's up to you to learn it. The world is open. You will get access to all the knowledge that you need to learn about something. But if we are given an occasion to do that, we have this extremely sad and unfair statement to give children, right? So my frustration is with this aspect of who gets to decide whether I can learn something or I can do something or not. I would not ever want to be personally in a situation where I'm told what I cannot or cannot do. I might choose not to do something about something. I might choose not to figure out how this clicker works. But if I wanted to, then I wouldn't want to be stopped, right? And extrapolate that to everything that you see around here, or in your workplaces or at home. So this is the discussion that we're going to have today, about creating a world where we don't have to apologize for the absence of an opportunity to understand how things work. And we don't have to force others to live with that sort of compromise as well. I mean, think of, let's say, 30 years back, or 40 years back, or even 25 years back. We could probably take most things apart. We could get them repaired. We could even buy spares for them or fabricate spares for them. And there would be people who would have knowledge of, let's say, how a television or a VCR or a radio set worked, or an air conditioner worked, and they would be able to fix it. Now, what does that say about the product? Well, number one, it's possible to access knowledge that is required to understand and fix something. And there are people who find it reasonable to acquire that knowledge and make a living out of using that knowledge for others' benefit, right? And it's completely optional. I mean, no one forces you to start a repair shop, right? I feel that's a value I can offer to society, and I might start a repair shop, right? So things were not so bad earlier because everything inside a hardware product was not built by software. But we started moving towards using a lot more software inside products. Today, the situation is that you have generic boards, and almost all the functionality of that hardware is implemented in software. Now, why is that? Well, that's a very nice and productive design decision. If I was a hardware developer, I find it tough to debug or change hardware after I have fabricated it, right? You build something like this, and you've forgotten something, you can't go and reproduce a batch of 10,000 units and fix the mistake, right? You can't do that. It's costly, and you would definitely get shouted at by someone for having made the mistake in the first place. But software is easy to fix. It's easy to upgrade. Software is easy to port to other devices, and so many more things. So that is the reason hardware designers have chosen to go with software to define hardware functionality over the years. It's a pragmatic choice, and it's also a very productive choice, but it also gives product developers a lot of control. A lot of control because they are the only people who have access to the source code of that software, and maybe even the hardware. And hence, unlike our free and open source software operating systems and other services and software that we use, we no longer have the ability to understand how that device works or what goes into getting that device to work, right? So again, you might ask, why hardware? Hardware is not the easiest thing to do, or maybe not all of us know people who play with hardware or who experiment with it. So I'll try to answer that question as well. I've given quite a few reasons why hardware is a nice thing to learn about and use. So the first thing is, if you're able to build your own hardware, you get an opportunity to retain or regain your freedom to learn and hack and explore and do things on your own, right? A lot of us don't want to do things on our own, which is okay. But if we do want to do things on our own, we should be able to do that. And learning about how hardware works, how to build it, or how to fix it, or how to hack on it, these are the activities that give us a higher level of involvement in those things that we own, that we are the owner of. Another aspect is, if you consider that each hardware has some sort of a processor inside it, and there is software inside it which is driving that hardware, well, that's a computer, isn't it? And now, imagine how many computers you have that you can play with, right? Instead of having just one desktop or laptop or a phone, now you have maybe 500 more computers if you look around you, right? From a keyboard to maybe a microphone or something that controls the brightness of lights. I mean, there is stuff all around us. A lot of it might run software. The ones that run software is a computer, in a way, because it does run some software on it. And now you suddenly have so many more computers that you can learn about, that you can program with. I mean, if you are used to programming hardware with your software with Python or Ruby or let's say PHP or C, well, some of these skills you can reuse when you build hardware or you program hardware as well. Yes, you will have to learn a lot more new things as well, but that's okay. We don't have a problem learning things. Also, we can achieve a much more diverse and a richer playground. I use this word playground in a specific way. I'll come to what I mean by a playground in a little while. But having so much diverse hardware around us gives us this richness of being able to learn about so many things, right? Now think of another thing. While all of us are going higher in the stack in terms of what we do with software or computers, there are certain skills which are becoming rare, right? So if you ask a lot of students, they might not even know that there is a bootloader, which is one of the first programs that is executed when the computer is booting up, and which hands over the control to the operating system after it's done its job. Now, the bootloader is one of the closest things to the hardware on your computer. Next would be the kernel as well. So the point is, skills which relate to working with hardware or managing hardware are becoming rare. They are becoming rare. And if some of us chose to build more skills in hardware, in doing a variety of things with it, I think that would be a good superpower for all of us. A lot of us, when we use software or we use services on the internet, we don't question where it's running, right? Of course, all software runs on hardware. Can it run anywhere else? It can't, right? So earlier, when people didn't know that the earth was round and they thought the earth was flat, the question was, what supports the earth in the air? So the prominent view was that there's a turtle and the earth, the flat earth, is on the turtle. But then what is the turtle standing on? The turtle is standing on the back of a larger turtle. And what is that one standing on? A yet larger turtle. And it's turtles all the way down. Now think about software that you are used to using, that you use on a daily basis, that you might program or deploy. Well, you might have stacks of it. You might have so many levels of virtualization and containerization, and you might have frameworks. Finally, it has to reach hardware, right? It's not software all the way down, right? And my point is, being able to understand some of these things can be a lot of fun, right? So why don't we all want to have more fun, right? Our work on software or technology doesn't always have to be serious, or it could be serious, but all the same we could have fun with it as well, right? And when you work with such a, when you work with unconventional computers, computers that don't come in a form that everyone thinks a computer looks like, well, you also get bragging rights, right? You've got software to run in places that people wouldn't expect software to run, and well, you have run it, so you have those skills and you put in that effort. I think those bragging rights are important as well. At the same time, there are also reasons why most people would not want to play with hardware. And well, hardware is expensive. If it fails, that failure can also be costly. Sorry, I didn't change that slide. If the hardware fails, that failure can also be costly. A lot of us feel that if we do something wrong, the hardware would just blow up. That can happen, but it depends on which part of the hardware blows up. Maybe it's a part that we can replace or repair. So there are reasons like this. A lot of us might feel that hardware is complex to deal with, and it's something, if we are designing it, then the process of developing, prototyping, testing it, and then putting it into production, that process can be complex. That process is, at least it's more complex than the process of doing the same thing with software. And that's one of the reasons why I don't want to deal with it. When we have a complete focus on building software or running software, we think maybe hardware is somebody else's problem. Why should we deal with it? There is somebody else who will deal with it, right? And by covering something with a somebody else's problem field, you say this is not my problem, it's somebody else's, you can very easily ignore it, right? And that's how we ignore so many things. We ignore proprietary software services, we might ignore uh, all sorts of proprietary software in our devices and so on. So what I meant by play is this. Yeah. So a playground, the way I define it, is a place where you're free to explore and experiment and do things on your own. You don't need someone's permission. There is nothing that discriminates against you, right? That's what a playground is. What is play? Well, play is something you do in the playground. Now, I've chosen a small quote by Maria Montessori. She was a educator in the late 30s and 40s. And she evolved this teaching method called the Montessori method that is used in a lot of preschools and even primary schools, even today all over the world. And one of the things that she would always talk about is using your hands and how children use their hands to learn things and explore the world around them. Well, since we can't hold software in our hands, we can definitely hold hardware in our hands. And that's a good reason to play with it, because holding it being able to hold it in our hands and fabricate it and building it enables us to learn so much more. So what I mean by the size of playgrounds here is that if today all you have is your phone and your computer and a server where you can run software and do things on, acquiring hardware or building skills on programming and deploying hardware will radically increase the size of your playground. Now you have so many toys and swings and stuff that you can experiment with, that doesn't have to be only used in one way. They could be repurposed and used in so many more ways, right? So it is our responsibility to enrich our playgrounds, not just for ourselves, but also for those who come after us, right? If we feel that knowledge and awareness about how hardware works is going down, unless we sort of build these playgrounds today, maybe in a few years, people's motivation to deal with hardware would decrease even further, right? So let's start with hardware. I believe everything starts with play. Linus Torvalds built the Linux kernel because he wanted to have fun. He wanted to understand how a specific processor worked, and what is a better way to understand it than to write an operating system, right? So if you wanted to understand hardware, a new chip, write an operating system which can run on it, right? So that's what he did, and we are all here partly because of what he did. Now there are a lot of things we can play with. I will not go into discussing each of these, but what I'm trying to say is that there is software everywhere. There is software everywhere. And if you want specific guidance on how you can play with, say, a weighing scale or a phone or lights or whatever else, we can discuss that. But the whole idea of putting so many things together in a single place was to highlight the fact that there is software in all those places. A lot of those places, all of those places are computers in a way. And our concept of fun can change if we understand that we have so many things to play with tomorrow. That's one of the most important things I'm trying to say. And, well, there is a hardware experience zone that we have set up there. And the idea of that zone is to give people a first-hand experience with all sorts of hardware. That's one of the aims that so many people collaborated to set that up and, manage it. One thing I can always confirm to you is that if you came and asked about how something works or what goes into getting it to work, somebody would be able to explain that to you. We wouldn't have to apologize and say, I'm sorry, we can't do that. Well, the whole purpose that hardware is there is because it runs free and open source software. Otherwise, it wouldn't be there. But not just that. How does it run it? What goes into getting it to run there? There might be a router which is not designed to run free software, open source software, but now it does run it. What went into getting that hardware from that place, from where it was designed to not run free software, to the fact that it now runs free software? Well, it took a lot of work by a lot of people all over the world, but today we can run free software on it, and that's exciting. That gives us so many more things that we can do with it. So, and if you want to see some of those things happen, like you want to see how a BIOS is flashed or how a free operating system like OpenWRT is installed on a router, or how we control lights or switches or something like that. There are so many devices there. Uh, I'm sure, if people don't know how to explain that to you, or they don't know enough to explain to you, there could be a document or there could be source code that we can read and understand together, and that would teach us what we want to learn. So it's not that we need to know everything, but we need to have hardware and software products that give us the opportunity to learn about how they work whenever we want to take that opportunity up. It's not that we will always do that, but the day we are curious about how something works, we should be able to sort of open it up. And personally, that's how I build our office or our home. Anytime we feel that we want to replace something or we want to have something, the ethic is that we will build it ourselves, right? So another sort of rhetorical question, what are the chances if you bought something today? It would not require internet access, or it would not send information about itself to its developers, or it would give you the freedom to hack and learn and do things on your own, and it would give you complete control, and in spite of giving all these things, it would still work, right? So most hardware that we buy today, it doesn't give us all this. It doesn't allow us any of these things. The solution, there's no single solution. There are certain things that we can buy which might give us these sort of benefits by default, but sometimes we have to put in a lot of effort in them. So this is something I say a lot. Unless we choose the hardware that we own mindfully, we will run out of places where we can run free Libre software on tomorrow, right? If we just blindly buy any random phone or any random computer or any, affordable voice assistant which is available on the market, and then we say, look, we want to run free software on it, I don't think that's going to happen. We have to choose those things very mindfully. And I'll tell you about a website that I'm building which will help us in that process as well. But the problem with choosing things mindfully is, if we are trying to make a different choice, and the choice we are trying to unchoose was not made mindfully itself, now making a different choice is going to be, it's not going to be easy, right? We don't always choose the phone or the computer we're going to use. We might accidentally just start using it. We might not have put in so much thought. But today we might have more awareness, and hence we are putting in this thought. So the process of going from that place of not being able to run free software on it to the place that we can might also involve that we have to choose a different hardware. So I have two very quick approaches that you could look at. There is a bottom-up approach. You assess what you need, and you decide whether you want to buy something or you want to build it yourself. There are always both types of options which are available to us. And then you choose those sort of things that can run free software. So assuming you have nothing, this is one approach that you could have. Or you could have this approach where you start with all that you have, and then you check whether some of that can be liberated, some of that can run free software. And if it can, you do that. The ones that can't run free software, maybe you throw them out. The point is that this might look like a costly activity, but if what you're trying to achieve is a no-compromise situation where everything you have around you absolutely has to run free and open source software, then maybe this is one of the only ways to do it. I use the word liberate in a specific way. The point was that there is a lot of hardware which is available on the market. We don't always have to build and fabricate hardware from the ground up on our own. There is a lot of hardware which is available. There are good chances that it could be made to run free software. Now, it was not designed like that, but we can liberate it using a few steps, and hence get the freedom to run whatever software we want on it, right? That is an exciting thing to do. That is also an approach which is very cost effective because the product is already available widely. It might also be available at a very low price or an affordable price, let's say a wireless router or a keyboard or one of those things. And what I've been intending to build is this website called liberatedhardware.org. What it would do is it would give you a way to browse products on it so that you could choose or you could get recommendations on products that are designed to run free software. Now, a couple of more points. I talk about this concept of designing and using hardware like a sysadmin. You know, what do we do when we're trying to administer servers or systems? We don't always write software to do something. Linux or Unix has this concept of pipes, which means that you take the output of one command or program and you send it to another program to do something else with it, and you can send that output from the second program to a third one and so on. So if you can achieve what you want to achieve by using pipes like this, you don't have to really write code, because code would be monolithic. Code would be one piece of one program which does exactly one thing, but pipes are extremely flexible and they are general purpose, and we can combine multiple tools in whichever way we like. So there is a way, I feel there is a way to use hardware as well like that, and that can actually ease our use of the hardware. So a lot of times we feel if we have to buy or get a hardware which does everything for us, which solves all our problems, then that's very complicated. Well, you're right, it is very complicated. But instead of thinking about developing or using hardware like that, think of pipes, right? Do whatever little you need to do so that you can do something, the rest of it, in a place where you have greater practice on, or you have greater experience with, right? Another aspect of such hardware is, what would it talk to? Would that hardware talk to proprietary services running on somebody else's computer? Or would such hardware talk to services that you're running maybe in your local network or on a server that you built yourself, or which is maintained by a community and you trust them? What would these sort of hardware products talk to? Well, if they talked to proprietary services, then they're not really solving all our problems. They are sending data about us to someone else. Now, again, using such software on somebody else's computer, what we call, what we also refer to as the cloud, that might be an easy way to get started, but that's not the only way to do things. And hence, cultivating hardware skills, system admin skills, and programming skills, the collection of these skills makes our use of hardware and our experimentation around hardware even more interesting, because it's not just that we're dealing with hardware or software alone, we're dealing with everything, and it's all connected. Some inputs about communities around hardware. How large are these? Well, they're extremely large. There are thousands and thousands of hobbyists across the world. And what I have listed around here are some of the common methods that people use to build these communities. So there are forums, for example, very, very large forums where people post and discuss things and collaborate on things. There are a lot of blogs where people post detailed instructions on how to do something. So if you are interested in something and there's a blog post there, you could actually replicate their steps. There are non-profits like the Open Source Hardware Association, whose sole purpose is to encourage people to create hardware and release it as open source hardware, and then they have a certification program for that as well. There are source code repositories, obviously. People publish their source code, and a lot of that source code is meant to run on diverse hardware, maybe microcontrollers. And one of the ways of learning how to write good code is to read a lot of code, isn't it? So you have a lot of source code like that. There are frameworks. There are chip developers who build communities around their chips, because otherwise people wouldn't use them, right? They have sample code. They also have forums and discussion groups and events. There are a lot of hardware designers like Adafruit, for example, who design hardware, who sell the hardware, and who also release a source code for the hardware. So if you wanted to have that piece of hardware, you always have two ways. You can fabricate it on your own if you have that equipment or the capability or the patience, or you could buy it from them. So buying it from them is not the only way to get access to it. Or you could learn how they've built it because they have shared the source code, and now you could adapt that source code for something that you want to build, right? We do that all the time with software. Now we can also do such things with hardware. There are a lot of licenses which are specifically designed for hardware. Of course, there is the open source hardware definition, which is similar to the open source software definition, which OSI, Open Source Initiative, publishes. And if you read those points, you will understand how to build and license hardware and call it open source hardware. Like I said earlier, there's a certification program for that. But all the other licenses that we use for software can also be used. There are copyleft licenses like GPL. There are non-protective and permissive licenses like the MIT license or BSG. There are also Creative Commons licenses. A lot of people share their designs using Creative Commons licenses, and the ones I would use or prefer to use would be CC by SA or CC by, which is an attribution license, or the public domain license. So those are something about licenses. Yes, there are challenges as well. It's not easy. I'll just summarize here. It's not easy. There are challenges. I spoke about some of the challenges earlier. And so one of the things that I'm proposing to do, and I had good discussions with Anand on that, is to build a sort of a free playground where we can invite everyone who wants to learn or experiment with hardware. We could invite them and give them a safe space to do that. So if you're worried or scared about doing something, well, why not come over and do it with us so that we can guide you. We can explain the nuances of that to you maybe. And the idea is to build a community, a large community around Bangalore or even beyond. Such communities don't really exist at the moment. And this is right at the point where software and hardware coincide. So it would be really worthwhile to do this. And all it requires is curiosity, sharing knowledge and the ability to collaborate and work with others. Because we don't do anything ourselves. We are always going to reuse others' knowledge and source code and whatever they've done before us, right? So, so these are some of the things I had to share. There are some websites which are coming up. I've been building these. None of them have been launched. But pinout.dev is a website to browse pinouts. One of the most frequent problems I have, even with boards I use very frequently, is that I forget printouts. And then maybe the pinouts. And I print it out and stick it on the wall, and then I can't just stick it around everywhere I work. So this is what I wanted to do, was build an interactive pinout page for most of the common popular boards, and build that in a manner that others can also contribute to it. There is a website called pinout.xyz which specifically does that for Raspberry Pi. But there are hundreds of other boards beyond that. So that is one of the goals. And yes, these are some of the products that you can see here. Just put pictures of them. So here are some of my contact details, and this is usually a last thing I like to tell people because I feel it fits into what we believe in and what we do in the open source and free software movements. What I cannot create, I do not understand. So the process of understanding something could also be the process of building something on your own. If you don't understand it, well, if you build it from scratch, you might understand it as well. And well, if you know how to solve every problem that has already been solved, well, obviously not every problem, but as many as you are interested in, then that gives you the basis of solving newer problems, or problems that people don't think are problems, or problems that people think are somebody else's problems, right? So the process of trying to solve them, or the process of trying to create something that you don't understand, is also the solution to owning problems. They don't need to be somebody else's all the time. If we start doing something about it, those problems are ours. And if we find a solution for them, if we can add value to the way people want to solve those problems, and they are helpful not just to us, but to everyone around us, right? So that is what I want to leave you with. Thank you so much.
Like software is kind of an infinite world, right? Because it's cyberspace, but hardware is not. It's like a physical limited space. The real world constraints will come in. So what really, what inspires people to get into hardware? Like the creativity piece, and then most problems are solved in hardware. I don't know, but this is unique. So that's one question. There is more broader philosophical, because you made a lot of philosophical points here, and so one thing I want to say is I've been to your office, and I think it's the most inspiring place in Bangalore. And whoever can take this shot, please go and visit Abhas' office. It's like a museum. and it's mind blowing. Right? And thanks for being part of this event. And I really look up to you because you are like an ideologically very clear, sorted person, and you live a very a principled life, right? And I just want to understand how did this journey happen, right? Because we all live in this capitalist world, right, where people just want to solve their problems, and not the conscious decision making is not a part of.
So the first question, you're right. Once you fabricate hardware, you can't really change it. But there are people who are creative in that way, creative with that part in many ways. For example, there is a board that I can show you. It's called a pneumato-opsis board. There's a community project called HDMI to USB.tv. The whole purpose of that board is very simple. If we are organizing a free software conference and we want to live stream it or record it, and we want to even record the output of someone's laptop because they're showing you something. It's not just a slide. Maybe they're showing you the output of a program or some hardware. Then we should be able to record that as well, and the video, and we should be able to switch with them and so on. So people developed this board called the pneumato-opsis board. Now that board has an FPGA on it. I think that board was fabricated around 2015 or 16. Obviously, it can't be changed now. But there were 2, 3 very smart things the designers did. By the way, that board is completely open source hardware. What they did is, they use an FPGA. Now, FPGA allows us to do 2 things. It allows us to do things like processing HDMI signals at very high speed, but with software. So the FPGA by itself doesn't do anything. It needs you to put a program into it which does it, but that program defines a processor maybe, or the functionality, which is like closer to the hardware than machine code in a way, right? So you're designing a chip on top of the FPGA to do certain things. So they did that. And now, even today, people are still developing software for that board. It's not finished. And there are other boards that people also play with. But that is foresight, because I can't change the hardware in future. Let me choose to use things where I can at least, the decision I'm making today is to use a chip which I can reprogram in future to add more functionality. Yes, maybe in future I might need more bandwidth or more whatever else. But the hardware is not where I'm going to lack. Today, even today, there are hardware features which the software on that board cannot use, because the pace of software development has not been as fast, and the number of people who understand how to do work on FPGAs is not so many. But if someone wanted to learn, that's an excellent board, because you can do so much with it. So similarly, there are people who build extension interfaces into their hardware for hardware that doesn't yet exist. The whole purpose of having general purpose IO pins and expansion slots in hardware is to plan ahead for those sort of things. So yes, some of this comes from doing the wrong thing. You build hardware and now you realize neither can it run the software that you want to write on it, nor can you expand it to serve another need. So the next time you build it, maybe you will put connectors on it, you will not make it extremely closely coupled. It's like writing a program and creating libraries out of it, or writing a program and making it completely monolithic and single purpose. So it's exactly the same thing. People design hardware in modules so that you can pick and choose what you want to use. People also provide space for future integration with whatever limitation that hardware has today. So it's not a problem which is like very well solved, but if we keep building it ourselves, so the problem is you might not even have textbooks which teach this to you, unless you worked under someone, or if you've studied design by others. Only then you might be able to sort of absorb these nuances of how to do it right, and there is no one way to do that, right? So that's one thing. Now, so I got started with hardware very, very long back. It was when I was in school probably. And it was fascinating because it allows me to fabricate something. So if I write software, I need a computer to run it, yes. And I can do so many things in it, yes. But the satisfaction of holding something in your hand, I mean, it's also a challenge. It's also something intimidating. How do I build an amplifier, or how do I build a small radio set? Now, those are very simple, maybe analog devices. The effort there is in terms of understanding how they work and why they work. But Today, we can do a lot of those things with software alone, right? You take a general purpose board, you can use that board to build all types of devices. But, so one is that it's always fun to look for challenges. After a while, what more can you do with a computer? Right? You want a buzzer you want to organize a quiz and you need buzzers for that. Yes, you could use a computer to build it, but let's say you are doing it in an era when laptops are non-existent or not common or very costly. Well, then you learn to build hardware. So a lot of times that would be my reason to do it. But another thing was, how much deeper can I go in terms of controlling the software which runs on it, right? Can I embed the Linux kernel onto the BIOS chip so that the moment I put on my computer, it boots the kernel and I'm into the user space within 2 seconds? Well, it's been possible to do that for about 20, 25 years. And people have wanted to do that because, let's say you build a cluster, you build a Beowulf cluster for supercomputing or something like that. You've got 500 or 10,000 or 1,000 computers, and you want to reboot the entire cluster. You can't wait for the whole thing to take 5 minutes to boot up or 3 minutes to boot up, right? You want to make use of those machines the moment you power them on. And one of the ways is to embed the kernel very deep into the hardware. So people did not start by designing it. They started by hacking on what was already there. They found ways around barriers erected by manufacturers sometimes, right? So one of the first products that we used to build something called DepotFix Office Server, and we used to ship it as a hardware product. So all you need to do is, you need to have power and network in your office. We'll give you this box, just plug those two things in, and it'll work. And it'll also work like an appliance. So it had an LCD panel and keypad on the front, and you could use that to configure its IP address, or disconnect dial-up, or connect dial-up, or schedule the connection of dial-up or disconnection. You could flush the print queue, or whatever else. So the idea was, if people fear that Linux is tough to use, we don't want to have it, well, here's an appliance. If you can use a washing machine or an ATM, you can use this as well. Right now, when we used to build it, and then we stopped building it because it became tough to build hardware or maintain it. If I send that server to, say, someone in Pune, I can't. How do I service it? It becomes costly to service it. But it's basically about the form of a product. Building hardware, challenges you to think about new forms of it. And I think that's the challenging part and also the fun part.